6 here, we are looking at solving rational equations. So this is building off of the simplifying rational equations that we started in 8.5. So one of the main ways that we will solve rational equations is through cross multiplication. So cross multiplication is really vital for this process because it takes our fraction form into non-fraction form, which makes it much more easily solvable. So really, the steps to solve a rational equation include cross multiplication, then solve the two leftover equations, and then finally check for extraneous solution by substituting that value back into your original equation. So taking a look here, I've got 2 equals x plus 2 over x minus 1. So the first thing that I would do here is I would make 2 a fraction. So I'd rewrite 2 as 2 over 1. Let me switch my pen there. So now that I've got 2 over 1, I would go ahead and cross multiply. So multiply diagonally. Now that I'm cross multiplying, I would take 2 times x minus 3 equals 1 times x plus 2, which I'll just leave that as x plus 2. Now that I'm here, I'm going to go ahead and distribute my 2. So that gives me 2 times x, which is 2x, 2 times negative 3, which is negative 6, equals x plus 2. From here, I'm going to subtract x and add 6. So I've got 2x minus x, which is just x, equals 2 plus 6, which would just be 8. From here, before I can really make that an official solution, I would go ahead and substitute 8 back into my equation. If you were to do the math, yes, 8 would be a solution. All right, moving down. For number 3, same exact process here. Go ahead and start by taking some cross multiplication. From here, I have negative 4 times x minus 3 equals 5 times x plus 3. Gonna go ahead and distribute on both sides here. So that would give me negative 4 x, negative 4 times negative 3, which gives me 12, equals 5 times x, which is 5x, 5 times 3, which is 15. Now I'm going to subtract 5 to my left side and subtract 12 to my right side. So negative 4x minus 5x gives me negative 9x equals 15 minus 12, which is just 3. Now I'm going to go ahead and divide both sides by negative 9. And that's going to give me x equals 3 over negative 9, which could simplify to be negative 1/3. Once again, before you can make this an official solution, you would have to substitute negative 1/3 back into your equation, but in this case as well, that would give you a valid solution. All right. Now over to the second page. On number 5 here, same exact process, except this time we're going to get a quadratic, so we'll go through it. So I'm going to start by taking the cross product. Okay, that would give me 3 times x plus 4 equals 2x times x minus 1. Now we'll go ahead and distribute. Okay, that would give me 3x, 3 times 4, 12, equals 2x times x, which is 2x squared, 2x times negative 1, 2x. Now this time, the only difference is I'm left with a quadratic, since I have an x squared. So since I have a quadratic, instead of moving all my variables to one side, constants to another, I'm going to move all of my terms to one side. So I'm going to subtract my 3x, and I'm going to subtract my 12. So that would leave me with 0 equals 2x squared. Negative 2x minus 3x is negative 5x minus 12. So now, to solve for x in this case, you would have to try and factor. So in this one, you would have to use the AC method since I have a trinomial. So AC, 2 times negative 12 gives me negative 24. And then my b value is obviously just negative 5. So two numbers that multiply to negative 24 and add to 5, well, that would be negative 8 and 3. I am going to factor by grouping on this one. So if that's not your preferred method, you can always factor any other way. So I've got 0 equals 2x squared minus 8x plus 3x, minus 12. Now we'll go ahead, group my first two terms, group my last two terms. My greatest common factor in my first two terms would be 2x, which would leave me with x minus 4. And in my second two terms, it would be 3, which would leave me with x minus 4, which all equals 0. All right. Once I am here, now I'm going to combine my outside two factors. So I've got 2x plus 3, x minus 4. So now remember, to actually solve for x, we're going to take both of our factors and set them equal to 0. So I've got 2x plus 3 equals 0, and x minus 4 equals 0. So 2x equals negative 3, x would equal negative 3 over 2. Oops. Go back to the pen here. And then over here, I would just get x equals 4. Okay, once again, you would have to substitute both of these x values back into our original function up here to check if they were solutions. But if you did check, you would see that they both are. All right, so that is quite a long process with the factoring. Let's do one more quick one with number 7. So in number 7, very similar process. The only thing that I would possibly advise with number 7 would be to factor this denominator first. Two numbers that multiply to negative 8 and add to 4. Well, actually, no. Let's not factor it. Let's just go ahead and take the cross product right away. Changed my mind. So if we were to take the cross product right away, up here I would have 4 times x minus 4, x plus 4 equals 4 times x squared plus 2x minus 8. Okay. One thing that I'm going to do that might be a little bit difficult to see is I actually am going to go ahead and multiply these two together at this point. The reason for multiplying this is that it simplifies what I have here and it allows me to combine like terms more easily. I'm also going to go ahead and distribute this positive 4. So combining these together, if I was to FOIL these, I would get 4 times x squared minus 16, which equals, and then go ahead and distribute, 4x squared plus 8x minus 32. Okay, I still have another set of parentheses, so I am going to have to distribute again, which would give me 4x squared minus 64, which equals 4x squared plus 8x minus 32. Okay, once again, I have a quadratic here. So I do think, well, actually I have a quadratic, but I'm noticing both of my x squareds are the same value. So they are going to cancel. So I'm going to leave the 64 over, and I'm just going to subtract my 4x squared. Okay, by subtracting 4x squared, that would leave me with negative 64 equals 8x minus 32. Now add 32 to the other side. That gives me negative 32 equals 8x, and x is going to equal negative 4. Okay, in this case, if you were to substitute negative 4 back into your equation, you actually would get an extraneous solution. So in this case, since that's the only solution I found, we really have no solution for this one. All right, so I know that was a lot of math for one video. There was a lot of factoring, a lot of combining like terms, all basics to algebra that we've covered all year. We'll make sure to cover a few more of these in class together. Please try the right set on your own. It would be good practice. All right, thanks for watching.